Now, in this question, we want to calculate the average atomic mass of silver that has two naturally occurring isotopes. And those two isotopes are going to be Ag107 and Ag109. And this 107 and 109, those represent the mass numbers. And the mass number is the number of protons and the number of neutrons added up. So those are always going to be a whole number. And this Ag107 has a atomic mass of 106.90509 AMUs, and it's going to have an abundance of 51.84%. And this Ag that has a mass number of 109 is going to have an atomic mass of 108.90476 AMUs and a natural abundance of 48.46%. And so what these percents represent is if I were to go and scoop up a random sample of Ag, 51.84% of that Ag, that silver, would have this atomic mass right here, and 48.46% of that Ag would have this atomic mass right here. And so the problem comes up where if we have these two different versions of Ag of silver, we don't know which number to put on the periodic table. And so what we do is we're going to take the average of both of these, and that's what number it's going to go on the periodic table. And we can't just take the average by taking this atomic mass plus this atomic mass and then adding them up and then dividing by 2, because this one right here, this Ag107, that's going to have a bigger contributing factor to the average atomic mass. And so what we'll do is we're going to take this 106.90509 and we're going to multiply it by this natural abundance, but in a decimal form. So it's going to be 0.5184, and then we'll take that number and then we're going to add it to the next one, which has an atomic mass of 108.90476, and we're going to multiply that by its natural abundance in decimal form. So that's going to be 0.4846. And whenever we do this calculation right here, we're going to get 55.4195, and then we're going to take that and we're going to add it to this one over here, and when we multiply these two together, we're going to get 52.78, and when we go to add these two up, we're going to get 108.1995, and so this right here will be the average atomic mass of both of the two isotopes, and so the answer choice is going to be B.